On the previous page of the notes, we looked at how to recognize our equations in their standard forms and looking at kind of the key characteristics of some of those equations. On this page, what we want to look at is how we can figure out what type of a conic we're working with before we even get into our processes. And that's an important thing to do because it'll help you know how to write your final answers. So for example, remember circles have to be equal to their radius squared, and our parabolas have some very specific equations or characteristics as well. So it's good for us to be thinking about that before we get into our work. So what you can see is that I've already identified some major things. I've highlighted some key things to look at to guide my answers, but there are a few more things that I could add to this. So the first thing is that when we're trying to decide whether something is an ellipse, a hyperbola, a circle, or a parabola, we can immediately eliminate parabola as a choice simply based on the fact that we have two squared terms. So for example, on this page, I only have two parabolas on this page, and they're right here. And they jump out as parabolas simply because there's only a single term that's been squared. The y values are not squared, so there's no way that those could be my circle, ellipses, or hyperbolas. So back to this problem, I can think of this and I can recognize that this is going to be ellipse because of two things. First of all, both of my signs are the same. I've got a plus sign here, I have an implied plus sign here. So I know it's not a hyperbola. Then I look at these two coefficients, and because these are different, I know that when I go to graph it, my horizontal distance and my vertical distances will be different. That makes it an ellipse. My next one on my circle, again, I've got two positives, but now my two coefficients are the same, which tells me the horizontal distance and the vertical distances will be the same. Same idea on my next one. Coefficients are the same, signs are the same. I have a circle. On my next one, I actually don't even need to look at these coefficients because I automatically know that this is going to be a hyperbola simply based on that negative. Because that's a negative and that's a plus, I don't even need to think anymore. It's automatically a hyperbola. Same signs, different coefficients gives me my ellipse. Hyperbole, you're probably catching on by now. As soon as you see that negative, but there's the plus out front, got to be the hyperbola. Next one down, again, automatically, you'll notice this time all I even highlighted was the minus on that one. This one should just automatically jump out to you as the equation of a circle. You've been looking at that for a long time now, so we've got a good circle right here, already in its perfect standard form. This one looks like our ellipse. Notice our denominators are different. As I talked on the previous page, that tells us that we're going to have a different horizontal distance versus our vertical. And moving on to the hyperbola, again, just this minus. That minus and the plus out front automatically tells me what I have. So we can probably zip through these remaining ones pretty quickly. Same denominators tells me my horizontal and vertical are going to be the same, and it's a circle, but this would not be in its proper form. This ellipse looks just like our problem that we had on number 9. We've talked about our two parabolas because they only have a single squared term. And then we move into the problems that are what the rest of our lesson is going to look like today. And you'll notice there's a lot of stuff going on here, but I actually ignore all of that and I just find the squared terms. And I can ignore everything else. Same signs, same coefficient, circle. Same signs, different coefficients, ellipse. As soon as I see these different signs, I've got a minus and a plus, I've got a hyperbola. There's my minus. My plus is out front this time, gotta be hyperbola. Same signs, different coefficients, ellipse, and same signs, same coefficients, I've got a circle. So this will be the first thing that we're also going to look at on our problems on the next page.